Okay, we're moving on. We're in 1.7. We're looking at property of real numbers. It says find the equivalent fraction expressions and simplify fraction expressions. Use the commutative and associative laws to find equivalent expressions. That means things that are equal. Use distributive laws to multiply expressions like 8 and x minus y. Use distributive law to factor expressions like 4x minus 12 plus 24 and collect like terms. Equivalent fractions are two expressions that have the same value for all allowable replacements are called equivalent. Equivalent expressions are two expressions that have the same value for all allowable replacements are called equivalent. And then the next one, the identity property of 0. For any real number a plus 0 equals 0 plus a, which simply equals a. It's the additive identity or the property of 0. Identity property of 0. And another one, make sure that you have your notes, because again, it looks so much better, but it's a times 1 equals 1 times a equals 1. I think the identity property of 1 and the identity property of 0 makes perfect sense. If you're adding 0 to something, you're not gaining or losing anything. In the same token, if you're multiplying by 1, you're not adding or losing anything. Alright, let's look at the next one. Evaluate. Remember what I told you about evaluate? It's like a value. We're looking for a number. So we're just going to plug in. X is now going to become 7, and Y is now going to become 8. That equals 15. If you reverse the order, Y plus X, you get 8 plus 7 is still 15. Now we're dealing with multiplication, and we're going to plug in. They're just showing you that it's commutative, that you can rotate them in the different orders, and the operations are still the same. So x times y, because 7 times 8, which is 56, or you can say y times x, which is 8 times 7, is still 56. It doesn't change it. Commutative laws. For addition, for any number a and b, you can change the order. A plus b equals b plus a, which is what we worked on a while ago when we did the substitution in for the x and the y, using the 7 and the 8 to get 15. And then the multiplication, the same thing. You can say a times b is the same thing as b times a, and that's when we did the substitution and we multiplied and got 56. So we can look at this one. It says calculate and compare. So if we look at the first one right here, let's look at this one. That gives us 4 plus 15, because we're used to doing things by parentheses. That gives us 19. Now if we look at this one, we get 13 plus 6, and that still gives us 19. So where those parentheses were, it didn't change our problem because everything was being added. So you can add in any order. Associative laws for addition for any numbers a and b and c. you can move the parentheses around. A plus B plus C, and then A plus B plus C. Just look at the difference where the parentheses are. And the same thing with multiplication. You can change the order. You've got A times B times C, and then you got A times B times C. It's just grouping. Okay, distributive law of multiplication over addition. Now this is where you really have to be careful. You're going to multiply everything that is in the parentheses by A. So A times B, that's where that comes from. And then A times C, and you get AC. And when you're dealing with it when it's negative, you have to account for that sign too. So it's A times B gives you AB, and then A times C gives you AC. And because it was negative there, you have to use that negative. So we're going to use distributive law. It's equal opportunity. Or some people think about Mario. He has to jump at all the letters. So you can say 4A plus 4B. That is your final answer. So this one says use distributive law to write an expression equivalent to each of the following. So we're just going to change things around a little bit. Again, think Mario's got to jump to each one. So we're going to get 8A minus 8B. This one you can rewrite if it helps you to see it visually. You can move the C to the front. So you could say C, let me get a parentheses there, B minus 7. And then you got CB minus C7. Or you can, if you think about it, there's proper order in math. So you put the letters in alphabetical order if they're grouped together, and you put the number first and then the letter. Those are the variables. It's kind of important to keep those in the proper order. And then we have one more. So now we're going to distribute through. Mario is going to jump on each letter, and we've got a negative there. So we've got to think about it. We have negative 5 times x. So it gives us negative 5x. Then we have negative 5 times negative 3y. So that's going to give us 15y. Then we have negative 5 times positive 2. That's going to give us negative 10z. Factoring is the reverse of multiplication. To factor, we can use the distributive laws in reverse. That means we're going to undo. We're going to find what two things were multiplied together to come up with that expression or the equation. So to factor an expression is to find an equivalent expression that is a product. What two things were multiplied. So let's look at the first one. I call it GCF. You look for the GCF. What's the greatest common thing that are in both of these? If you don't know, break it down. So we have 6 times x minus 6 times 2. That would work, right? So if you pull out a 6, you're left with x minus 2. And that one's factored. Let's look at this one right here. What would all these have in common, can you think? I would say 8. So you have 8 times x plus 8 times 4 times y minus 8. So if I take an 8 out of everything, it's like dividing each section. So if I divide that by 8, I'm left with x. If I divide this by 8, I'm left with 4y. Ooh, be very careful here. Now, if you divide something, if you divide negative 8 by positive 8, it's going to give you a negative 1. So be very, very careful what you come up with. So that's negative 1. So that's our final answer. 8 parentheses x plus 4y minus 1. Alright, let's do the next one and see if you can figure it out. I think these have a 7 in common. So if I pull out a 7, I'm left with x minus y. And let's look over here. Think about your GCF. Greatest common factor. If you did a factor tree, you could start there. I'm thinking since they're all divided by 2, I would get 14 would give me 2 and 7. 12 would give me 2 and 6. And 20 would give me 2 and 10. So if I divide each term by 2, we're going to see what it is. So now I'm left with 14z divided by 2 gives me 7z. 12x divided by 2 is going to give me 6x. And make sure you keep your signs. Negative 20 divided by positive 2 is going to give me negative 10. And that's your final answer, is factored. A term is a number, a variable, a product of numbers and or variables, or a quotient of two numbers and or variables. Terms are separated by addition signs. If there are subtraction signs, we can find equivalent fraction or equivalent expressions that uses addition signs. The process of collecting like terms is based on distributive laws. So this chart shows things that are alike so that we can look at it. Terms in which variable factors are exactly the same, such as 9x and negative 5x, are called like or similar terms. They have the same power, the x does. They're up to the first. Same thing here with the x and the y. So you could add those together if it told you to. These right here, you have 1y, but this is really 9y squared, and they are not the same thing. I think of it as like, unless it's crazy sock day, you normally wear the same matching socks, so you would wear crew socks or knee-high socks, but you wouldn't wear one knee-high sock and one crew sock. It just wouldn't make sense in my opinion. So this one here and this one is written as 4b squared. Now if it had just been 5a and 4a, you could have put those together, but because that b is squared, you can't put those together. So now we're going to combine like terms and see if we can find something. These are identical, so we can add the coefficients. That's the 8 and the 2, and we keep the variable. What about these? We can subtract the coefficients. So we get 3 minus 6, which is negative 3, and we just keep the x. Let's look at this one, see if you can come up with it. I would say the a's go together. I have a 3a, and remember it's understood that it's a 1a. And then I have, let's see, I have a 5b. Ooh, that's an ugly color. I'll have to change that one. And a negative 5b. Those cancel, don't they? They go away. And then I have, let's use black. Then I have a constant. The reason it's constant is it doesn't have a variable. So I have a 2 minus 8, so it gives me negative 6. So your final answer is 4a minus 6. Alright, we're going to do exercises from the text. Again, this is your cue to stop and look at the margin exercises and try to work some on your own. And then you can start the video back if you need to. So for number 5, I have 3y over 4y. Well, the y's are going to cancel, or they're simply going to say 3 times 1, 4 times 1, because these kind of convert to y over y. So your final answer is 3/4. That's not that hard, is it? Okay, the next one we're going to do is number 7. So we have 5xy over 40y. Well, we know that the y's can go away. The x is going to stay, but 5 goes into 40 how many times? 8 times. Very good. If 5 goes into 5, 1 time. So you really have x over 8. Alright, exercise number 10, it says to evaluate xy and yx. So the first time we have xy is going to equal negative 2 times 5. That gives us negative 10. And then yx is going to equal 5 times negative 2, which is still negative 10. So you can write it down both times since it's the two different problems, but you get the same answer. Alright, exercise 20. Let me turn my page. Alright, we've got two different ones, and it's based on groupings. So let's look at A. We have 7 times 3 plus 6. So it gives me 7 times 9. which is what? Can you tell me? 7 times 9? Very good. It's 63. Now let's look at B. We have 7 times 3 plus 7 times 6. That gives me, what, 7 times 3 is 21. And then 7 times 6 is 42. That still gives me 63. Okay, again, your suggested homework is 1 through 125, every other odd. So you're not doing every other one, and you're not doing every odd one. Okay, it's every other odd. And if you're doing this for flipped, we'll work on these in class. If you're doing these for a regular class session, then you need to do these homework. If you're doing these for the online class, then you need to take the time and look at them if you need extra practice. All right, see you next time.